Well, good evening. Welcome to Space Oddities. How is everybody out there? Thank you for joining us on this Tuesday evening. We've got a bit of a packed house this evening, so let me quickly go around everybody. Hello, Daz. How are you?
I'm lovely, thank you.
Well,
Lovely
that's a
and
matter of
warm.
opinion. How are you? Roger, how are you?
Oh, I'm good.
Yeah, ditto.
Top of the day.
Good. Got a bit of a lag on your sound there, Roger, but never mind. But let's hope it sorts itself out. Michael, how are you? Show us the thumb. There we are. Michael has recently had the plaster removed from his thumb, or his thumb removed from the plaster. So after his injury, because he's been sucking his thumb far too much for years, and it finally took a toll. So good to see you getting back to normal, Michael.
Yeah.
And we're joined this evening by a very special guest, old friend of ours, Paul Evans. How are you, Paul?
I'm good, thank you. Yeah, all good.
Good.
Just back from my holiday, so freezing now, But
excellent. And I'm sure it was a bit of a shock returning to Ireland, wasn't it?
It definitely was about 18 degrees shock. Yeah.
Oh, yeah. I had that not so long ago, coming back from Dublin, and it was more than that. It was a real shock getting off that plane, as you know.
Yes.
And Paul's going to be talking to us about a very special event, which is Irish Astronomy Week, which is next week, which we're looking forward to seeing the results of. So Paul's going to be telling us about that. Keith, how are you?
Fine, thanks. Yeah. It's either freezing or raining where I am, and that's about it, really.
Yeah, we actually had some rain yesterday for the first time in, I can't remember.
Yeah, we're getting all of yours.
Yeah, I know. And we actually had a thunderstorm, and they promised us a day of heavy rain, and we got about 3 hours of medium rain, and that was it. So the drought situation here continues to get worse, and nobody knows what the solution is, but we'll find out, no doubt. Lovely to see you. Keith is going to be talking to us this evening. He's going to be doing the second part of the feature that he started last week, that is to say, Astrometry, and had some really good feedback about that, Keith. You'll be glad to know. So we were looking forward to the second part of Astrometry, which I believe this evening is going to be about astrometry in the solar system. Is this correct?
Correct. It's intended to show you some of the ingenious ways in which we've worked out how far away things are.
Right. Excellent. And we welcome from the United States, Mr. Lou Mayo. How are you, Lou?
I'm doing well. I'm having great fun with my new Sea Star, taking images, which I mercifully have not sent into the gallery so as not to embarrass Roger. I am especially grateful today that both of my thumbs work. So I'm doing well, thanks.
I also have a Sea Star, Lou, and I love it.
Yeah, everybody's getting a Sea Star. I must get one. I really must.
It is. So, I call it the Ford Model T of things. It's not actually the best car, but it's affordable and drivable by so many people.
Yeah, absolutely. Yeah, and yes, I shall definitely have to get one at some point. So there we are, and we welcome from deepest Yorkshire the lovely Rachel. How are you, Rachel? Haven't seen you for a while.
Hello, I'm good. I'm just laughing because he's shouting so loud next door. So if you can hear the baby, I'm sorry. No, it's clear here. So I'm hopefully leaving Johnny and Isaac in control of the observatory, and they're going to try and take some pictures.
Right, superb.
I'll take credit for them later. It's fine.
Right, great. Well, lovely to see you. Rachel will, of course, be presenting this week's gallery. And don't forget, if you would like to have your astronomical image featured in the gallery, then it's very simple. All you have to do is to email it to spaceodditieslive@gmail.com. One image per email, please. And if you could entitle the email something like gallery image or something like that to make it easy to find in the inbox. We do ask that if you want to feature them on a particular Tuesday, you get it into us by the Sunday, 2 days before, so that Rachel's got time. Rachel or Roger, depending on who's doing it this week, has time to put the gallery together. If you get it in after Sunday, then we will, of course, carry it over to the next gallery. And, we're looking for any astronomical image, but not necessarily taken with a telescope. Could be a skyscape, could be something nice in the night sky taken with a normal camera, could be anything. anything remotely astronomical, we do love seeing your images. And of course, with this wonder telescope we were just talking about, the C-Star, it's making it a lot easier for everybody to get involved in astronomical imaging. And you only have to look at astronomy groups on Facebook to see the place is absolutely flooded with people's C-Star images, because, this is a revolution that people just haven't been able to take quality astronomical images before in the same way and so easily. So there we are. All right, then. Now, slight technical hitch here. I see that video you were referring to, Daz, earlier was the Irish astronomy.
Oh, I do apologise.
Video. It just seems to have disappeared off the queue in the server.
Yeah.
So we obviously have a problem there. So Paul, I think we'll come to you first if that's
Yes,
all right.
of course. Yes, let's do that. Yeah.
Okay. Well, let's see if we can arrange the windows a bit better so that we can. Yeah, that's a bit better. You're a bit bigger now. Okay, Paul. So Irish Astronomy Week, something that happens every year. Tell us all about it.
Well, this is actually the second year, so it's not quite,
each year.
But actually, I mean, the guy who thought it all up, a friend of mine, Ronan Newman from County Mayo, has been talking about this for many years. Actually, it's something he wanted to do, really as a follow-on from the Irish Year or the International Year of Astronomy 2009. Do you remember that? All those years ago, we did a lot around Ireland at that time, and Ronan wanted to do this, and it was never the right time to do it, and of course, then I became chair of the Irish Federation of Astronomical Societies during COVID, for my good fortune, when everything sort of came to a stop. But I kept things going by doing, star guide videos, and we had some Zoom sessions and all that sort of thing. I learned Zoom and all then. And at the end of it, Ronan came back and sort of said, "What about my old idea of having an Irish Astronomy Week?" And actually, I just went, "Yeah, why not? Let's sort of, get out of COVID by doing something to get involved and involved with each other again and looking up and all that sort of thing." So last year's was the first Irish Astronomy Week, and three of us got involved, actually, myself and Ronan himself and Sinead Mannion from Connemara, who don't you, because Sinead has been on here before, hasn't she?
Yeah, absolutely.
And so the three of us kind of got it all together. And Ronan did all the work, and he's done all the work this year. He's like he's a dynamo. He just gets going on writing to people and phoning them up and all that stuff and putting things together. He needs help from the likes of me and from Sinead. Sinead has done all the website side of things, and you should go and look at the website. It's irishastronomyweek.ie, nice and simple. It's an
right. I'm going to put that in the chat.
Yeah, put that in the chat so people have got a chance to see.
Let me do that now.
So we did it. So the target last year and this, I forget whether we actually hit the target last. We got into the 90s. We started off with the idea we'd have 100 events across Ireland in a week. Wow! And then we had all those delicate little questions to address, because we sort of said, well, you wanted to call it 32 counties, and yes, there are 32 counties on this island, and actually, astronomy-wise, we all work as one, because that stretch of water between the rest of the United Kingdom and this bit of it, you make traveling back and forth quite expensive and difficult. Whereas while we stay here, we're all one grouping, and we were all one astronomical grouping long before there was a North and South Ireland anyway. But calling it the 32 counties kind of sets certain people off. So we thought, no, we'll try not to use that term too much. And so we called it 4 provinces, and that was more politically acceptable.
Right.
Munster, Leinster, and the other one I've forgotten now. So anyway, we did it all. We had I think we got into the 90s of events across Ireland last year, and we're up to 83 at the minute, and we'll probably get to 90 probably by the time it happens.
Fantastic.
still going on at the minute, and I'm doing a few things myself and a few other things as well, because I'm also I'm current president of the Irish Astronomical Association, which is the main amateur body in Northern Ireland. And we got a little lottery grant, so I'm going out to schools and talking to them. They gave us a bit of petrol money on the condition we went and talked to people and tried to get more people involved in astronomy. That's what the game is. But I'm also doing IAW talks, one up at the library in Ballycastle, and I'm doing a big talk about the total solar eclipse at Armagh Observatory and Planetarium.
Oh, fantastic.
Which I'll sort of talk about that quite a lot, because I'm actually going to Niagara Falls on the 8th of April.
Are you really? Oh,
I am indeed.
Well,
yeah, we're going to go to Texas. And then I thought, well, we've been to Texas, and like the totality is like sort of 4 minutes of your holiday, and you want to go on holiday somewhere else, really. But I've never been to Niagara Falls, so just to find there was a totality there, I thought, yeah, let's do that. And the other thing that was really good about that side of it, just to pick that destination, is that the Americans, they, along that line of totality, the price of everything just skyrockets. Now, I looked at going in 2017 and I kind of gave up when I was offered a log cabin in Wyoming in the middle of nowhere for 2 nights, the crucial 2 nights, either side of the totality, for $4,200, and I kind of like,
wow, what?
Yeah. But in Canada, for some reason, I don't know if it's regulated or whatever, but they hotel rooms are the same price they were any other day of April, so we just booked them and said, right, that's it, and good old Aer Lingus have taken us over nice and cheap as well, so it's
fantastic.
So it'll be a great time, whether we see the eclipse or not. Well, we will see it go completely dark and all that, but there's always a chance that you don't quite get the totality or whatever. But it's end to end, the whole thing is like 2 hours from first bite to last, but 3.5 minutes in the middle of the important bit.
Yeah, excellent.
It'd be my fourth. But
I've never even seen one. Mind
you absolutely have to.
Just waiting for 2026 when we have one in Spain.
Yes, and indeed 2027 you get another one.
Exactly.
And I know a man with a hotel in the centre line, right down the south for the 2027. The one you want to see, 2028, it's got to be one of the most seen eclipses ever. 2028, because it goes right through the middle of Sydney.
Gosh, that's handy.
So 5 million people without going anywhere are in it. So but anyway, I digress from all that. But Irish Astronomy Week, it's happening. We hope for good weather during it. It's kind of thing. I come back to my sea star as well. Do you know what I'm going to try and do with my sea star? Around that full moon sort of time, March, then I'm going to see how many Messier objects I can get.
Oh, good luck.
And from here, 90 is not an unreasonable thing. I made during lockdown a video of with a Stellarium script of what order you do it in to get, to get. I mean, you sort of start as soon as the sun goes down with. There's something over in the west there that appears just after sunset, and then you just keep on going through the night until you get something like M30, I think, is just about possible before dawn. So might have a go at that. Extra batteries for the sea star and all that sort of thing. But,
absolutely, yeah. So as far as the Astronomy Week goes, what are the big highlights? What are the big events that people might like to attend?
There are lots. This is the beauty of it, that there's so many events of so many people doing different things all about the place that you've got to go to our website, irishastronomyweek.ie, and there's a whole, you can search it by area or type of event or whatever, but there are just lots of people, some of whom haven't spoken for a good few years, coming out and doing talks to people about their particular interests and all. I'll just share a little story from last year with you. I don't know if I've mentioned this before, but I did a talk in Ballymena Library last March. And it was just a general astronomy talk, and I got, a fair range. I got about 25 people came, which wasn't bad. And I just talked them through some basics of what you can see in the sky, and how to go and see it with binoculars and telescopes and whatever. And I got some really good questions back. We had a great banter and all that sort of thing. And then this elderly gentleman, I think I can use the term because he's actually older than I am, I think, says to me after, he says, "There's something I want to discuss with you." I'm going, okay. He says, "I've seen a film that proved that men never went to the moon."
Oh, no.
And I said, okay, so tell me what the basic premise was. He said, well, it said that their suits would have inflated as soon as they went outside, and they'd never have been able to get back in. I said, well, okay, that did happen, not on any of the moon landings, but in 1965, Alexei Leonov, the cosmonaut, became the first man to get out of his spacecraft in space. And yes, his suit inflated and he couldn't get back in. So with that remarkable, presence of mind that people with the right stuff have, he goes, well, I'd better let the air out then, and actually undid the valve and quickly got back in while he could. Of course, they did share enough intelligence even at that stage that they were told, look, this is a problem, guys, don't do that one again.
Yeah, absolutely.
I then talked him through the Neil Armstrong defense, which was that because Armstrong was not very long afterwards asked that very question, didn't you? Aren't we watching a Kubrick movie here? And he said, well, we thought about faking it actually, and we sort of went through the thought process and said, well, we're going to have to actually build and launch the rockets because there's going to be so many witnesses to that we can hardly just put it on television and people will say, well, no, I was in Florida that day and nothing happened. There'd be too many, witnesses to that. So, and then, the fact that there's 400,000 people involved and they would all have to be in on this and sworn to secrecy, despite the fact that, the press would offer them vast sums of money to spill the beans, and that never happened. And then, of course, there was the Russians who were watching, they were in a race. So they were watching everything like hawks and whatever, So everybody else was happy with that, but he wasn't, and that's life, But, so the punchline there was, of course, that it was just easier to send 3 men to the moon.
Yeah, absolutely. Yes, and in fact, on the Mitchell and Webb comedy series, of quite a few years back now, they did a sketch about exactly that, that it would be easier and cheaper to send them to the moon rather than actually fake it. Yeah. And they did a few about conspiracy theories about Princess Diana and Kennedy, and they were absolutely hilarious.
They're back. Tell you what, you had the latest one. You keep an eye on these things, don't you, Andy? But, what they're saying now is that since I did my first 2 talks about Artemis, I'm doing another one on Monday to the University of the Third Age up in Coleraine, and of course it's got to be completely different because the whole thing has gone back a year and maybe more. And some of the things are being rethought and all that sort of thing. And of course, the conspiracy theorists are sort of saying, guys, how come this is so difficult? You've done it before with 60-year-old technology, haven't you?
You can't win, No,
and
whatever you do, you can't win with these idiots. You really can't.
Really can't. No. But I just let them entertain me. They won't get to me. I consider them figures of fun,
Yeah. Well, in fact, there was a comment on one of our videos on our YouTube channel that I quickly deleted. Somebody going completely over the top, saying, everything you talk about on your channel is a lie, and you're all pawns of George Soros, and et cetera, et cetera, et cetera. Some predictably some American loony, and. And I just, the present company accepted, of course, Liv.
I was advised a different technique to dealing with these people, actually. And that's that when you hear a conspiracy theorist, what you do is you throw back an even bigger conspiracy theory out.
Oh, yes.
And
Yes.
so when people start talking about, did men land on the moon, you sort of go, you believe in the moon?
Yeah. Yeah.
Because there are things that there's all sorts of them. There's birds aren't real; they're drones.
Oh no, that one.
Oh,
one was an intentional
Yes.
conspiracy theory.
People believe it. Yeah, but
just done by a guy, a complete genius, to test whether people would actually believe that birds aren't real. That they were all actually replaced by CIA spy devices.
Yeah.
And he's been absolutely horrified how many people actually believe it. And he said he wishes he'd never started it because have you seen his van? His van's all done up. Birds aren't real. It's all fake, and and people are actually, loads of people are actually believing this.
Fantastic.
And, I know. All right then, Paul. Well, listen. Thank you so much for telling us about Irish astronomy. We'll let you get off now, and we wish you all the very best of luck with it. Obviously.
Thank you.
And do come back afterwards and tell us how it all went. We'd love to hear about.
Are you going to play the video?
We're going to try and play the video. I have got it resurrected, so we're going to play the video. And this is Paul's video.
I'll take any questions that arise from it if you want. Yeah, I'm not in that much.
Okay, okay. If you're not in any hurry, then let's play the video. And just if we get technical problems, we apologise in advance. But it seems to be all right at the moment. So.
Welcome to Irish Astronomy Week 2024. This year we've adopted the theme From Your Garden to the Stars. The week runs from the 9th to 16th of March this year. We've timed that to give a favourable viewing of the moon and planets and some other things that we can see in the sky, which we'll talk about later. And we'll also talk about the rich history of Ireland. But our goal here is to provide opportunities to connect with the universe, to promote an appreciation and understanding of the night sky, and to enjoy it in a non-intrusive and non-destructive manner. Today, let's embark on a journey through the fascinating history of astronomy in Ireland. A story rich with discoveries, contributions, and the relentless pursuit of understanding the cosmos. Our tale begins in ancient times when the Irish, like many ancient civilizations, observed the heavens with awe and wonder. The alignment of ancient monuments such as Newgrange suggests an early interest in celestial phenomena. However, it wasn't until the arrival of Christianity in the 5th century that recorded astronomical observations began. One of the earliest Irish astronomers of note was a 7th century monk, Adamnan, who documented a solar eclipse in his writings. But it was during the Middle Ages that Ireland truly began to make its mark on the astronomical map. Monasteries such as Armagh and Clonmacnoise became centres of learning where monks meticulously recorded celestial events, laying the foundation for future astronomical endeavours. In the 17th century, the golden age of astronomy, Ireland saw the emergence of exceptional scholars like Sir William Rowan Hamilton, mathematician, astronomer and physicist. He was the Andrews Professor of Astronomy at Trinity College Dublin and Royal Astronomer of Ireland, living at Dunsink Observatory. Hamilton was Dunsink's third director, having worked there from 1827 to 1865. It was the appointment of William Parsons, the 3rd Earl of Ross. As the President of the Royal Society of Dublin in the 19th century that truly propelled Ireland onto the international stage of astronomy. Lord Ross, armed with his groundbreaking invention, the Leviathan of Parsonstown, a 72-inch telescope, shattered existing astronomical boundaries. With it, he observed and sketched detailed images of celestial objects, including the Whirlpool Galaxy and the Crab Nebula, contributing significantly to our understanding of the universe. The Leviathan was the world's largest telescope for 72 years before being overtaken by the 100-inch on Mount Wilson in California in 1917. Moving into the 20th century, Ireland's influence in astronomy continued to grow. Notable figures such as Annie Maunder, the Lady Computer of Strabane, who conducted pioneering work in solar astronomy, leading to an understanding of the period known as the Maunder Minimum, and later Jocelyn Bell Burnell, who co-discovered pulsars, made significant contributions to the field.
Today, Ireland boasts world-class astronomical facilities such as the ILOFAR radio telescope in Birr and the Dublin Institute for Advanced Studies, where research into cosmology, exoplanets and space weather continues to push the boundaries of human knowledge. In conclusion, the history of astronomy in Ireland is a testament to the enduring curiosity of the human spirit. From ancient observations to cutting-edge research, Ireland's astronomers have left an indelible mark on our understanding of the cosmos. As we gaze up at the stars, let us remember the tireless efforts and remarkable achievements of those who have come before us, inspiring future generations to continue exploring the mysteries of the universe. After that look at the history of Irish astronomy, let's look forward to what we might see in the sky during Irish Astronomy Week 2024. The first item of interest is not in the night sky, it's the sun, because solar cycle 25 is well advanced and we're headed towards a peak next year in 2025. But it is very, very lively and is delivering a lot of sunspots with flares, and hopefully this will lead to aurora activity, which is particularly visible around the time of the equinoxes. This is due to a phenomenon called the Russell-McFerran effect, where the magnetic fields of the Sun and the Earth line up, which makes it far more likely that a solar storm will cause aurora visible in the sky. And the good news is that certainly from northern parts of the island, these can be quite visible, and actually come quite a way south too on good occasions, so there's a chance that we'll see Aurora Borealis, which is a beautiful combination of red, green and sometimes blue and purple lights in the sky. Next up, we have the moon phases for the week, and we've chosen the week so that it starts with the new moon, with the thin crescent moon being visible on the 11th. And also you need to be very careful about this, but you may get to see the planet Mercury close to that crescent moon. The moon will rise and get more easily visible during the week, and we get almost to a half moon on the Saturday. Now just on Mercury, you can see it during the week, just after sunset, and I must stress at this point, for safety reasons, you must not go looking for Mercury while the sun is still at all in the sky, because 1, you won't see it, and 2, you may damage your eyes if you inadvertently look too close to the sun. But Mercury is there, it is small and bright, in fact sometimes it can be brighter than the brightest star Sirius, but not many people have seen Mercury because it's always very low in the sky and close to the sun, so it never really makes it out of the twilight. In terms of other planets, there aren't that many visible, to be honest. Jupiter and Uranus are the only other 2 planets that you'll see during Astronomy Week. And now Jupiter is very big and bright. As soon as the sun has set, you'll see Jupiter come out towards the southwest. And it's still pretty huge, not quite at its best, which it was at the end of last year, but it's still bright, and if you look at it through binoculars, you can see the 4 Galilean moons, and if you watch those from night to night, they will obviously be rotating around Jupiter as they'll move from side to side over several evenings, and if you look at Jupiter through a small telescope, you'll see the equatorial weather bands and possibly even the Great Red Spot, which is a storm bigger than the Earth that has been raging on Jupiter for at least 300 years. Close to Jupiter you could find Uranus. You'll need a star map to find that. Some people say they've seen Uranus with the naked eye because it is at the magnitude 5.8, which is just on the cusp of what it's possible to see. But most people need binoculars or a small telescope where it shows up as a small green blob. These 3 are the only planets visible during Irish Astronomy Week 2024. Now turning to the deep sky, Irish Astronomy Week has plenty to offer, as we still have the constellations of winter, so looking south as soon as the sun has set, we can see Orion the Hunter. And Orion is a spectacular constellation in its own right, as well as being a great signpost to other constellations as well. If you find the 3 stars of Orion's belt and a line across the middle of Orion, and then look downwards from the middle of that, you'll see Orion's sword. And in that sword is a fuzzy patch visible to the naked eye, and that is the great Orion Nebula, Messier 42, and new stars are being made in that nebula all the time. Through a telescope, and actually as well through a camera, it's quite spectacular. Also from Orion we can follow the belt first of all downwards, follow the 3 stars in the belt downwards until we come to a very bright star, and that is the brightest star in the sky called Sirius. It's quite near to us, which is why it's so bright. It's actually, in terms of stars, it's fairly unexceptional, but as it's only 8 light years away from us, so it looks very, very bright to us. If you look a bit downwards from there, you can see the structure of the constellation Canis Major, and that's one of those constellations that does look a bit like what it's supposed to be, in that you can clearly see that Sirius is at the head of the dog and then it has the hind legs down below it. Back to Orion itself, and we can see the very bright star Rigel, which is definitely blue in colour at the right foot of Orion. Rigel in fact means foot in Arabic. And then look up to the opposite corner and you'll see an orange star or reddish star, Betelgeuse. Now, Betelgeuse is a red giant, and at the moment, this being the end of February, it's looking dimmer than usual and has been quite variable for a long time, but more so in recent years, which leads some to suspect that it's now going unstable and could explode anytime soon. Now, in celestial terms, that doesn't necessarily mean this week or next week, but maybe in the next 10,000 years or so. But if that happens, it will become very, very bright at night, brighter than the full moon, and will cast shadows at night and will be visible in broad daylight, and this will go on for several weeks or even a few months. But it may be a long time in our terms before that happens. Following the belt of Orion upwards, we come to another orange star, not quite as orange as Betelgeuse, but orange nevertheless, and that is the Eye of the Bull, Aldebaran. It is in the constellation of Taurus the Bull, and you'll see it's surrounded by a V-shape of other stars, and that's the Hyades cluster. And it's important to realise that Aldebaran is not actually a member of the Hyades cluster, it just happens to be in the same direction and is brighter because it's nearer to us than the rest of the stars there. Follow that line upwards further and we'll come to a little cluster of 6 or 7 stars, and we call that M45, or the Pleiades, or the Seven Sisters. And it's a good test of eyesight because different people see different numbers of stars, and if you look through a telescope, actually you can see there's a couple of hundred of them. As the night goes on, we can see the constellations of spring coming into the sky, and the most obvious of those is Leo the Lion, with the bright star Regulus at its foot. And again, Leo is one of those constellations that does look pretty much like what it's supposed to be. The backwards question mark at the front end of it being a pretty good rendition of the head of a lion, and then the stars to the left of that looking like the body and tail of the lion. Carrying on further left from there is the great galaxy cluster of Virgo, with lots and lots of galaxies in quite a small area of sky. And if you take photographs of that with a telescope, or look through a powerful telescope, you can actually see them all individually, all different shaped galaxies. Well worth having a look at that part of the sky. So that's a quick run around the deep sky objects visible in the sky during Irish Astronomy Week, and I hope that you'll enjoy having a good look around. This video has been produced by the Irish Astronomy Week 2024 team, us being Leading Light, Mr. Ronan Newman from County Mayo, Sinead Mannion from Connemara Astronomy Club, and me, Paul Evans, from the Irish Astronomical Association and Irish Federation of Astronomical Societies. Keep safe and keep looking up.
Well, there you are. Nice video, Paul. Let's hope it has the desired effect.
I hope so. Yeah, it's just it's a fairly lightweight thing that gets people interested. I hope, and if I've done it right, But there we are.
By the way, do give our best to Sinead, won't you?
Certainly, yes, indeed, yes.
And tell her, she's welcome to come back and chat to us anytime.
Of course.
So she's always welcome. Of course she is. Okay. If you have any questions for Paul about anything he was talking about or in the video, please do put them in the chat. Don't hesitate to do that. In the meantime, we're going to go over to this week's viewers gallery with Rachel. So, Rachel, what have we got in the gallery this week?
We have another short mix of, as usual, high quality stuff from the viewers. So let's dive in. Kicking off with setting the bar high. Martin Stubbs has sent in the Tulip Nebula, and this is really, really...
That's beautiful, isn't it?
Really pretty.
That's fantastic.
Not a sea star, probably. No?
Yeah, definitely not a sea star.
No.
No, this one's using, I think it was the narrowband filters, wasn't it? Gone for a Hubble palette with this one, but it's such a pretty nebula. And I love the little flash of colour. It's just cut off on this image, but obviously it's sort of mid-left. When you see that in wide scope, it's almost exactly, like I want to say Aquafresh. It's like a little red, white, and blue splodge.
No, you won't say Aquafresh, will you? No.
But it's really nice.
Other toothpaste are available.
Other toothpaste are available. Yes,
but not in the same colours as Aquafresh. So
that's true.
So yeah, well done, Martin. Then we've got just the titled Moon by Dave Garside, just to help me realise what it is.
Nice, Dave. Nice.
So he's dusted off his 8-inch dob and took a picture of our little
lovely
satellite buddy. So yeah,
that's lovely. That's really cool. Look at that.
Very good.
So, yeah, well done, Dave.
Yes.
Then swiftly moving on, we've got a Sharpless nebula by Jerry. Jerry's always busy. I don't know when Jerry takes these. He seems to have so much each week. I don't know if he takes them every week or if he just.
I reckon he's in perpetual darkness wherever he is. But probably Antarctica or somewhere. Look at that, Jerry. That's fantastic. Well done.
Yeah.
Very good. And finishing our old friend Lee. He's done a May Milky Way, so this is from 2023. Obviously, as most viewers know, Lee's in Cornwall, and he's always lurking about in the darkness at 2 a.m.
Oh, Lee, that's fantastic.
Wow.
Oh, it's fantastic.
That is lovely. Yeah.
Very nice.
Nice signature, too.
Yes, absolutely. Yes.
Very nice. So,
Very
well
good.
done, Lee. And that
Very
is our very short and neat and sweet gallery.
Thank you so much, Rachel, as always. So there we are. That's the gallery. And as I said earlier, if you'd like your picture featured in the gallery, just mail it to us at spaceodditieslive@gmail.com. 1 image per email, please. And if you could title it gallery entry or something similar, that would be much appreciated so we can find it in the inbox. Okay, moving on then. Just before we go any further, just a couple of housekeeping things. We'd first of all like to say thank you to those of you who joined us for our live coverage of the Odysseus landing on the moon. That was quite a nail-biting evening, wasn't it, guys? A late night as well. So thank you to all of those who stuck with us during the 3.5 hours that we were streaming, and it was all over the place because we didn't know exactly when it was going to land. They kept changing the landing times, but we got there in the end. But we'll talk about Odysseus more in the news a little later. And we'd also like to say a big thank you to all of our viewers for helping us reach the dizzy heights of 70,000 views on the channel, which we achieved this week, another milestone. So Space Oddities is moving in the right direction, onwards and upwards. Of course, 70,000 views is nothing compared to, say, a Taylor Swift video, which might get 10 million views. But we like to think we do things a little better than Taylor Swift in the world of astronomy. So
most of those views are just from Roger.
Well, exactly. Yeah.
Is it on
Don't give it away.
fan.
We said we wouldn't tell, for goodness sake. So he apparently invented the term Swiftie. So the answer for one. So anyway, moving on. I think we've better stop there. Really, yeah. Thanks to everybody. You've helped us get to 70,000 views on the channel, and we're very, very grateful for that. So thank you for your support, and of course, thank you to all of you who have bought us coffees. Last week we had a large influx of coffee. We had gallons of the stuff bought to us last week.
We were buzzing.
It was very impressive. So thank you from the heart of our bottoms for all of that. And you're very kind. And if you would like to keep us in coffee, as usual, you can scan the code. And we will. I'll just pop that up on the screen. So if you'd like to buy us a coffee, all the money helps to keep Space Oddities going. And here's the code to scan. You can just, if you've got a QR scanner on your phone, you can just scan the code. It has also just appeared in the chat. If you look in the chat, there's a link to go and buy us a coffee. All money does go and only to the upkeep of the channel and paying the bills that we have to pay. So thank you very much for that. Don't forget, we also have the Space Oddities merchandise. So I'll quickly go through that as ever. The luscious Space Oddities T-shirts available in 10 colours. And these are £20, including UK postage and packing. And if you would like one of those, again, scan the code. And with summer approaching, they make the ideal gift to you or anybody else for buying one of these. They're absolutely fantastic T-shirts. And also we have a new design for Space Oddities, new piece of merchandise. We've only been promoting this for the last couple of weeks, a lapel design T-shirt with the design as it says on the lapel. Again, same price as the T-shirt, £20, including UK postage and packing. And then last but not least, we have the item of apparel, which is probably more appropriate in the weather you're getting at the moment. Because I was reading today that the UK, as of Thursday, is getting 114 hours of continuous snow. So you've got all that to look forward to, guys. And what you want to do is to wrap up worn in your Space Oddities hoodie, of course. 6 colours available in 2 designs. The pull over the head one, where the design is on the front, and the zipper type, where the design is on the back. And these are £40, including, again, UK postage and packing. For any foreign orders for any of those items, please add another £10. So there we are. Where else can you get this quality merchandising?
The hoodie is so soft as well, by the way. I've got the hoodie. It's so soft. It's really good quality.
Is it really? I haven't actually... sampled the hoodie, as it were, but the T-shirt's great. I love my T-shirt. So there we are. You've got a hoodie, haven't you, Daz?
Yeah. I got hoodies, T-shirts. Got the lot.
I've got the hoodies as well.
Yeah,
really soft.
Yeah,
Soft and snuggly.
I got both the hoodies, both type of hoodies.
Is that the hoodie you wear when you're down with the kids?
Down with them, yeah.
Excellent.
There's a question just quickly for Paul.
Mm-hmm.
It's obviously from somebody who's very intelligent. He's probably good looking as well.
Is that from you, Daz?
Paul, is there anything online during our...
I was just putting my hand up, actually, because I'd seen that same question myself, Daz. But now, mostly it's live events, but do go and have a look at the website, irishastronomyweek.ie, because one of the events in there definitely is a talk about AirSat 1, and that is an online event. And AirSat 1, you may not appreciate, it was Ireland's first satellite, which went up quite recently.
Right.
And totally successfully as well. So that is definitely one thing that is online that I know about.
Okay.
So most are real live, getting back to reality sort of stuff. But that one is online, so you can pick that up certainly.
Great, thank you, Paul. Absolutely brilliant. Moving on, of course, he's felt a bit left out up to now because we normally come to Roger first, but we've changed the order around a bit this week. And we're going straight over to Roger. What's up in the sky, Roger?
Well, you're about to find out.
Mm-hmm.
So here we go through the last few days of February and into the beginning of March. So here we go. Currently, we'll be getting the phases going back to the last quarter during the weekend. And last night was the waning gibbous moon, which I quickly snapped. And there we go. But now this is a picture of where Odysseus is at the moment. And we know it's down near the South Pole, but when I had a look to see how far down it was almost right down on the limb there. And this is a close-up of the same photograph, and that is roughly the site where Odysseus is at the moment. And this picture was not taken with a sea star.
No. I was just going to say, actually, if you tilt your head, you can probably see it because it's on its side, isn't it?
Yeah.
Yeah. So it is in that vicinity, but you can see how near the bottom of the moon that it actually is.
Yeah.
Terminator
very close to the pole, isn't it?
Is that the crater Clavius? Just
yes, it is. Yes.
Yeah.
And at the right phase, obviously a day before this picture would have been taken, you would have got the eyes of Clavius just appearing over the rim there.
Yeah.
Clavius is my favourite crater. I'll tell you why.
Oh,
it's great for outreach things.
It's great. No, it's great for outreach purposes because I tell people it's the same size as Northern Ireland.
Is it really?
That
Wow.
is to say, it'd be about 2 hours drive in your car from one side to the other.
Wow.
Right. Okay.
And
Interesting.
it is, of course, where the base in the film 2001: A Space Odyssey was situated.
That's right.
Ah, okay.
Yeah.
Can we move on now?
Thank you for being here, by the way, Paul. Paul's got the pep up now, so let's say a big thank you to
See you
Paul.
guys. I'm going to go and
Thank you. Yeah,
talk.
All right.
Thank you for being here,
Bye,
Paul.
Paul.
See you soon. Don't be a stranger.
Okay. Cheers.
Okay.
Good luck.
Right. So this is currently what we can see at the moment, although this was yesterday and not today. But the sunspot group is still quite an interest. And then we've almost got a vertical lineup of sunspots moving across as well. So
Yeah.
looking at
there is. Sorry, Rog.
I'm going to say there is a lot of activity if you look at it with the hydrogen alpha of the flares and stuff that's all going on around that area there as well.
Yeah, that big sunspot is 3590, and it's been firing all the way across over the last week. And it actually produced the biggest flare for this cycle. It produced an X 6.37 flare the other day, but unfortunately it wasn't associated with a coronal mass ejection, so there we didn't get any aurora or anything. There was a peak in the KP index on Saturday, but it wasn't that bright. It probably up in maybe northern Scotland you may have seen something. So
Here's
there it is.
a closer view of it.
Yeah.
Wow. So this is much bigger than the Earth, presumably.
Yeah.
Yeah.
Yes, yes.
Oh yeah, several times.
You could
bigger.
probably put a whole Earth in either side of that
Yeah.
double spot, so to speak.
Because I did see some pictures today on Solar Ham, and it is sort of like showed this in very, very close detail, but also in different wavelengths. And they also marked up the negative poles of these sunspots and the positive poles. And basically what it was is what's on the left. You see there's a little group on the left. They are all negative. The big area where it's black and off to the right, they're all positive. But right in the middle, then there was just off the center, there was a positive pole. But right in the middle of the two of them, there was a negative pole. Now, when the poles get mixed up like this is when we get lots of action. And as you said, Roger, this has been really, really busy all week.
Yeah, this is just another view as it gets near the edge in hydrogen alpha, and there, as you can see, there are some prominences on the edge there as well.
That's lovely.
Amazing.
Again, not taken with a sea star.
Funny that. That's amazing.
Okay.
You're lost, Roger.
So, okay. Right, so through the week we still have Jupiter, although it is now heading towards the west. This is drawing at 10 p.m. So a setting Jupiter, but still a good view in the night sky. And obviously we still got the winter circlet in the sky, but we've now got the galaxy season constellations of Leo and Virgo coming up from the east as well. So things are moving on now, unfortunately. And there we go. And as we go through to the morning, I've got this without the bright glare of the dawn sunrise coming up through, just to show you how close Mars and Venus are still relative to each other during this week.
Yeah.
Although you have to have a very good low horizon to be having a chance even to see it, providing you don't get too much glare of the dawn sky blaring out and covering Mars probably. So you might see Venus, but you'll be very lucky to see Mars really in the glare of the dawn sky. But they are relatively still close together, although they were at their best during last week, unfortunately. But there we go. And I've got a few little comets of mention that might be of interest. We've still got Pons Brooks, which is travelling through Andromeda for the week. And as you can see, it's still getting brighter.
It is.
It's due to get brighter through into April. But obviously, you have to be in the right position to be able to get to see it. But,
and it is worth pointing out, I think, that I've seen several articles online saying that we're definitely going to have a naked eye comet in April. As we know with comets, nothing is certain.
Nothing's guaranteed.
Nothing is
guaranteed. But there could be a very bright one in October.
Ah, really?
The premise of that is -4.
-4?
-4, which is sort of Venus magnitude. But
that definitely won't happen.
We'll see how that goes.
That definitely won't happen. Whenever somebody makes a prediction about a bright comet like that, it never happens.
But if you want another one, this is in Ophiuchus, and that's one of the Pan-STARRS comets. That one is a little bit low, but it is not too faint. But there is an opportunity for another comet. And if that one doesn't float your boat, then we've got Comet C2023A3 Simpson Sun Atlas, which is also
that's very faint, though, isn't it?
Yeah, it's a little bit fainter. It's in the magnitude 12, but another opportunity if you do have to get your sea star out and take some pictures of comets.
Yeah.
So that comet was discovered concurrently with an automated system, Atlas, and another observer?
Yes, it was, yes.
Yep.
Anyway, this is a bit of news from the James Webb, and this is a best evidence yet for a mission from a neutron star and recently observed supernova known as SN 1987A. And this was originally released last year. The top right image shows light from a singularly ionized argon-2 captured by the medium resolution spectrograph. And the image on the bottom is from the light from a multiplied ionized argon from the near infrared spectrum, which
this is
indicates that there might be a source of high energy radiation, most likely a neutron star.
This has been the most amazing story for those of us that have been following this supernova since it exploded in 1987. If anybody is interested, the BBC in 1988, one of the Horizon programs called Death of a Star, which I believe is on YouTube, was a fantastic documentary about the supernova and the guy who discovered it. Well worth checking out. Anyway, this has been a most amazing story because it started like any supernova, and then the blast from the supernova caught up with the gas that had previously been ejected from the supernova during the death throes of its progenitor star, which was known as Sanduliak 2. And the shock of hitting that already emitted gas caused incredibly high temperatures, glowing X-rays. And as you can see on the image on the left, this sort of pearl necklace around the original site of the star, which is clumps of glowing gas where the shock occurred. And scientists at the time were fairly certain that a supernova of this size would have left behind either a black hole or a neutron star. But for decades, none were visible because presumably whatever was at the center of the explosion site was hidden behind dust. And that dust has gradually been clearing since 1987. The first tentative identification of a neutron star came with an infrared study about, 2 years ago, was it now? Something like that. But it was never confirmed. And now the James Webb has, as Roger said, got this evidence that there's definitely something, probably a neutron star, right at the center of where the star originally was. So this is great news for those of us that have been following the saga of supernova 1987A. And it just goes to show that, we've got the evolution and death of stars right, because this is another confirmation that the death of massive stars actually do result in either a neutron star or a black hole, depending on their mass, of course. So this is a great event, and I'm hoping that there will be more follow-up observations just to definitively confirm that this is what the JWST has seen. But I think it's exciting. There you are.
And Andy, I think if we have images of the supernova in the high energy, in the X-ray regime,
yeah,
and we here have images at the low energy, the infrared regime, I suspect you could do a little math and come up with some good limits for the mass of the central star.
Yes, indeed.
Yeah.
And again, hopefully it will fit in with the predictions. So there we are. Right then, sorry, Roger, sorry to interrupt.
That's all right. That concludes my part of the program.
Right.
Yes.
Okay. So,
yeah,
I mean, as I said, I'm particularly thrilled with the idea that they finally discovered a neutron star at the beginning of the supernova. Oh, look who's here! It's Isaac.
Yay!
It's the Space Oddities mascot. So. Yes. Hi, Isaac. Is he gorgeous? There we are. Hi, Isaac.
Just woke up, maybe.
Just
there we are.
On your mention of that BBC program about 1987A, I remember it well.
Yeah. And it's one of my collection of Horizon programs, which I've got 240 something Horizons.
Right.
And going back to 1964, and my mission is to collect all of them. But so many of the course don't exist because the BBC wiped them in the early 70s to reuse the videotape. So a lot of these 1970s Horizons just don't exist anymore, unfortunately. All right, well, let's move on. Let's go on with the news now, and let me just sort this out, and we will have a look at the news. So the big news of the week, obviously, covered live on Space Oddities, was the landing of Odysseus on the moon. Sadly, it tipped over, and the reason for this was, we'll talk about that in a second. So here's an artist's impression of how it actually looked. Tipped over, very sad, which means it's been unable to carry out its scientific work. But it did prove that America can land at the South Pole, and America's first soft landing on the moon since 1972. So historic for that reason. And here's Tony Bella did this sequence of drawn images showing what happened. It came in too fast horizontally, we think, caught its landing pad on a boulder or stone of some sort, and gradually tipped over. Quite gently, of course, because it's only 1/6 gravity. So there was no real damage to the spacecraft, but it did mean that some of its scientific experiments couldn't work. And the latest news is that we're expecting the spacecraft to die very soon because it can no longer recharge its batteries due to the changing angle of the sun. So this is very unfortunate. So here's the landing site shown on the left. Malapert, near Malapert, a crater, as Roger pointed out to us earlier, and on the right-hand side is a really zoomed-in image of the spacecraft on the surface. You can see the spacecraft on the surface. You can't actually see whether it's on its side or not, but we know that it is. And there we are. So that's the last resting place of Odysseus.
So that's a lunar reconnaissance orbiter image.
Yes, it is.
Restructured its orbital path to get that image. And one thing I think we're waiting for, it was in the planning. I don't know if it happened. I don't know if the spacecraft is declared dead yet, but there were 2 cameras that were supposed to be kind of launched during descent that could look back at the at Odysseus and watch it land. That did not happen.
No.
But at least one of those cameras, even in its tipped over position, is in a place where they could fire it and look back at the tipped over Odysseus. And I don't know if that's happened yet.
So basically, they decided, because of the navigation problems before the final descent, they decided not to jettison the Eagle Cam, as it's called.
Eagle Cam.
And the plan was, as you said, to eject it while it was on the surface. But I don't think it's actually happened. If it has happened, they haven't said anything about it. So I don't know. It would be great if they had, to get at least try and get one image of the attitude of the spacecraft, for future reference, so they can try and work out exactly what happened during the landing phase. But I haven't heard anything about that. Now, here's the only one of two images actually returned from the surface, from the lander itself. You can see that you can see the landing legs sticking forward there, which of course they wouldn't be if the spacecraft were standing up. So this is the other one hardly showed any detail at all. So this is the only real image of note to be returned from Odysseus on the surface. And we now know exactly what caused the problem with the navigation. You see that the lander was meant to use a LiDAR system. That's a laser ranging system for autonomous navigation. And it used a system of 3 lasers. And before launch, there was a switch on the lasers to stop them being activated accidentally on the ground and burning somebody's eyes out, basically. And there was a switch that could be set to turn the lasers off for health and safety reasons while it was on the ground. And somebody forgot to switch them back on again before the flight, so that when they tried to use the lasers, they were basically switched off. That's when they asked NASA if they could use this experimental laser navigation system that NASA were going to try out. And NASA said yes. And that's why the spacecraft did an additional orbit before landing, because they needed to hack into the code to patch it through to the spacecraft's own navigation system to join the NASA system together with the intuitive machine system. And, the NASA system was experimental, and it looks like, as I said, the spacecraft had too much horizontal velocity on approaching the landing site, and it fell over, basically. So that's a real shame. Lessons learned, and onwards and upwards. And Lou, in a little while, is going to be telling us about the next mission that will attempt to land on the surface of the moon.
Yes, and just a quick comment, Andy. I watched the news cast about the status of Odysseus, and they were saying how proud they were of their ground system teams, because it would normally take about a month and a half if you wanted to switch from the intended laser ranging system to the NASA package to develop the algorithms and do the testing and all this. And they did it in an hour and a half.
Yeah, I know. It was an incredible effort. And, they should rightly be proud of themselves, because it wasn't an easy job. They must have some ace programmers working for them. That's all I can say, because it was not an easy task to tie those two systems together. So well done, Intuitive Machines, and well done, NASA as well, of course. So, lessons learned, and onwards and upwards. The next news item is quite interesting. The James Webb Space Telescope continues to question our understanding of the evolution of the early universe. And I want to make it quite clear that nothing that the James Webb Telescope has discovered invalidates in any way Big Bang Theory, or indeed our general picture, our helicopter view, if you like, of how galaxies formed in the very early universe. But the Webb has found this galaxy, a very early galaxy, and it poses big questions. Now, the galaxy in question, excuse me, dates from just a few 100 million years after the Big Bang. And you can see the timeline of the universe here. So the first stars arose about 400 million years after the Big Bang, and the first galaxies not long after that. So why is this galaxy causing a lot of scratch heads at the moment? Well, it's bigger than the Milky Way for a start, and it's difficult to explain how a galaxy that old, and precisely 11.5 billion years old, could have evolved to be bigger than the Milky Way in that time. But interestingly, the stars in it are 13 billion years old. So these are made up of some very, very early stars during the first, a billion years after the birth of the universe. But this galaxy doesn't appear to have been built on dark matter seeds. Now, the idea is with galaxy evolution that dark matter forms a sort of a framework or a seed for galaxies to develop around. And astronomers don't think that this early in the universe there was enough clumping, if you like, of dark matter to form a seed on which a galaxy could develop. So this is a real puzzler because it looks to have developed without the assistance, if you like, of dark matter. It's a real head scratcher. And another weird thing about this galaxy is that it went through an initial period of star formation. That is to say that the stars are 13 billion years old, which seems to have existed, some of them at least existed before the galaxy came together. But the galaxy then went through a period of star formation quite rapidly and then just stopped forming stars altogether, which ties in, I believe, with the idea that you need not just dark matter for the formation of galaxies, but dark matter to prompt and continue star formation for whatever reason. So that's really weird as well. It went through this brief starburst period and then just stopped forming stars altogether. So that's another poser from the web, which I'm sure will be unraveled in time. They're looking for similar examples, obviously, to compare them. But the James Webb continues to do what it was designed to do, basically, and that is to show us new stuff and to point out holes in our current theories of galaxy evolution, which the Webb is managing to do quite successfully. So watch this space. We'll keep you up to date with all of the latest on the James Webb and everything else, of course, here on Space Oddities. Now, there was a new spacecraft in town this week. Finally, after years of delays, Blue Origin's New Glenn new rocket rolled out for the first time. And there you see on the right, Jeff Bezos on the right, looking up, obviously quite proudly at Blue Origin's new baby, the New Glenn rocket launcher, which they hope is going to compete, at least in some degree, with SpaceX in the satellite launching market. On the left is the CEO of Blue Origin, which he has what I think is a very funny name. His name is Dave Limp, and he's the CEO of Blue Origin. This is a rocket that's well overdue. It's been promised so many times. And we're still not sure, actually, whether this is actually a genuine rocket or whether it's yet another mock-up. Because up until now, when asked to show evidence that they were making progress with this rocket, all Blue Origin have shown is mock-ups of the rocket. And there's still a question over whether this is actually a real rocket or just a mock-up. So we will see. But talking of new spacecraft, it's soon going to be launch time for the Dream Chaser. But before we talk about that, let's talk about what's happening on April the 22nd. This is the first crewed launch of the Boeing Starliner flight, first flight to carry astronauts up to the International Space Station. This is a big deal as far as Boeing's concerned, because as you may know, up until now, this spacecraft originally commissioned by NASA. At the same time, they commissioned SpaceX, both companies, to develop a spacecraft to supply the International Space Station and resupply it with cargo. And the SpaceX Dragon has been a runaway success. It's shortly to deliver its 8th crew to the International Space Station. It has performed flawlessly. The Boeing Starliner, on the other hand, has been an unmitigated disaster. And brave indeed are going to be those first astronauts to fly in it, flying on April the 22nd. And if we can, of course, we will bring that to you live on Space Oddities. Now, the other big new spacecraft is the Dream Chaser 1 by Sierra Space. This is their space plane that's going to revolutionize transporting not just crew but cargo to not just the International Space Station, but the new generation of space stations that are going to be built over the next few years. And this is a wonderful vehicle flying on top of the Vulcan Centaur rocket, which is a new rocket from the United Launch Alliance. This will be the Vulcan's second flight. and the first one went off without a hitch. So we're looking forward to seeing this beautiful spacecraft launched at the space station on sometime in April. We'll give you a date as soon as we can, and again, if we can, we will cover that for you. And if you want to know what the Dream Chaser looks like, here's the Dream Chaser. Beautiful space plane, very futuristic, and the first few flights at least will not have crew aboard. It'll be flying autonomously, but this is the crewed version, as you can see, that's designed to carry, I think, up to 6 astronauts, if I remember rightly. Daz, can you remember? Was it 6 or 8? I can't remember.
I think it's 6.
Yeah, I think it's 6. Yeah, thanks. They'll be flying in comfort as well, because it'll be more like flying in a jet airliner. This is a spacecraft that launched atop a rocket and then lands on a runway, and it can land on any runway in the world. And I know that the Spaceport Cornwall are trying to attract the interests of Sierra Space in using that as a landing strip, Spaceport Cornwall, which would be fantastic. But it can land on any runway in the world, because it doesn't, unlike the shuttle, which needed a runway a couple of miles long, the Dream Chaser lands in very short order, so it can land at virtually any airport in the world. So we're looking forward to seeing the Dream Chaser in flight, and this is an artist's impression of what it will look like. The first one is named Tenacity, and attached to it in this image you can see its solar panels unfurled with a cargo unit on the back of it, which it can carry.
Can I say, with the Sierra Space, there is a memorandum of understanding between Spaceport Cornwall and Sierra Space.
Oh, great, is there? Oh, it's got that far. That's good. Thank you, Mike.
Using Cornwall as a landing site.
Fantastic. Well,
and also the crew capacity is 3 to 7. So
3 to 7, yeah. Thank you. So, people in Cornwall could be seeing this flying through their skies before too long, which would be wonderful. Okay, and then moving on, talking of the SpaceX Dragon, the Dragon for the flight of the next crew to the space station arrived in Florida. This is Crew 8, and then was mated with the Falcon 9 launcher. And you can see that there. I noticed that the SpaceX engineer here has got a shamrock on the back of his shirt. I wonder if there's an Irish connection there that we're not aware of. That'd be interesting. So the capsule was mated with the Falcon, and it's a beautiful vehicle. And so far on its 7 flights that it's completed so far has performed flawlessly. So well done, SpaceX. We'll look forward to another success in April with this one. Lastly, there's been a bit of a first in astronomy. Astronomers have managed to map the magnetic field of an entire galaxy cluster for the first time. This is El Gordo, which in Spanish means the fat one. This is the fat galaxy cluster. This is an image 6 million light years across, and they've managed for the first time, using the Chandra X-ray telescope and other telescopes, to produce a complete map of the magnetic field of the whole galactic cluster, which has never been done before, and it should teach us a lot about how galaxy clusters work and how they evolve. So there you are. So that's the news for today. And that's it, basically. So if you've got any questions, anybody, put them in the chat. We'll be quite happy to answer them for you. Let's just talk about Odysseus for a little while longer. Lou, what are your thoughts about Odysseus being a NASA man, as it were?
Well, it was a success in so many ways. Apparently tipped over on its side. Many of its instruments are pointing up as opposed to being covered and pointing down. So presumably they got data beyond just the few images that we've seen. And as I'll tell you in a moment, there are plans for the IM-2 and IM-3 already in place. So what do you do when your spacecraft falls over? You build another one.
Exactly.
Yeah.
Okay. So following on from that, Lou, can you tell us a little bit about the Viper mission then?
Yes, I can. Let's bring up my PowerPoint.
Okay, so that's your Osiris Rex presentation.
No, it's called, that's not the right one. That's not the right one. Hang on.
Okay, while you're sorting that out.
Just hang on. Yeah.
Easily done. Easily done. Keith, have you got any thoughts about Odysseus? You're on mute, Keith, by the way.
There we go.
You're on mute.
Sorry, I've been on mute because I've got a bit of a cough.
Thank you for doing that.
We need to have a new competition for the first person to land a probe the right way up on the moon, actually.
Absolutely. I mean, Odysseus was desperately trying to emulate Japan there, and didn't quite make it.
Well, the Indians did, didn't
they? The Indians did, yeah, absolutely.
Yeah, Chandra 3, or was that Chandra 3?
Yeah. And I mean, it just goes to show how resilient and brilliantly engineered these spacecraft are, because even being upside down in the Japanese case and on its side in the Odysseus case, the spacecraft was still working. And as we found out yesterday, in fact, the Japanese lander has actually come back to life after the lunar night. It survived the lunar night and is still transmitting. So this is fantastic news. So that, you know, the engineers who build these things are geniuses. So there we are. Okay, all sorted, Lou?
We're all set, I think.
Okay, right. Okay, let's. It's still saying Osiris Rex here, though.
Well, I have both of them up. Do you see them?
You do. Okay, let's put this one up then. There we are.
Trying to sneak on an Osiris Rex. You're too smart. You caught it. So I have some slides here, and Andy's already done an outstanding job in presenting the status of Odysseus.
Oh, thank you.
I have one extra picture that I think was not in your slide deck. If I can advance here, it's this one.
Ah, there we are.
And this was taken before touchdown. So just another image of the Odysseus. So let's talk about what happens after Odysseus. See if I can advance forward here. I have to do them one at a time, I think. There we go. Okay. So as I was saying, this is not the end. This is not the end for the IM series. IM2, which I guess hasn't been otherwise named yet, is due to launch at the end of this year. I think these launch dates have been pushed forward a little bit, but as of right now, launch at the end of this year. So I'm sure they will flip the switch this time. And then there's an IM3, and I don't know what the landing date for that is, but I imagine it is sometime in 2025. So the IM series will live on, and they will learn from their mistakes, as happens with all space flights. Beyond that, let's move on. Beyond that, we have another lander, in fact, a rover, that is also scheduled to launch near the end of this year. The Volatiles Investigating Polar Exploration Rover, or Viper. This mission is laser focused, as we say, on finding water at the South Pole. And it has a series of instruments that are just perfectly tuned for doing this. Okay, so here's just a little fact sheet, probably too many words to put on a slide, but late this year is the launch, 100 Earth days is the mission duration. It has 3 spectrometers on board. We'll be talking about that. Whopping top speed of about 0.5 mile per hour. So let's dive a little bit more into Viper. Okay, so there are 4 primary instruments on Viper. And they're going to operate kind of in sequence. So this thing's going to roll around the south pole of the moon. And its neutron spectrometer will be looking at a depth of up to about 1 meter or 2, I think, looking for hydrogen emission, looking for free neutrons that are emitted when galactic cosmic rays interact with lunar material. And when that happens, there is a neutron flux. This neutron flux has an energy associated with it. And from that, they can get kind of an idea of whether hydrogen is present. But they don't know if it's present in water yet. So the next step is to take the Trident instrument and drill down about 1 meter into the lunar soil, where they have made a NSS neutron detection, and pull up that material, and then look at it with a near-infrared spectrometer called, interesting name, NERVUS. I guess we'll all be a bit nervous as we wait for the results. And this will tell us whether or not that hydrogen is bound in an hydroxyl molecule, OH, or free hydrogen, or in fact water. Water has a unique molecular spectral feature that has to do with its rotational vibrational lines. And so the NERVUS mission will be able to detect that. And then there's a mass spectrometer. Of course, mass spectrometers rely not on seeing something from afar, but actually pulling in particles into a magnetic field, shooting them by the field, looking at how much they're deflected. And then from that deflection angle, you can tell something about the mass of the particle, and from there, its elementary composition. And so this will be looking to characterize the lunar soil in other areas besides water. So this is a pretty cool little machine. And as I mentioned, it's going to land. Whoops, I'm trying to make slide changes on my version, not on the one on Space Oddities. So it will land, again, way down here at the very bottom on the south pole of the moon. All of these, of course, south pole, because that's where Artemis will eventually land. Artemis 3, the first landing mission with people on it, and also where we suspect there's water ice. And so from orbit, we have some potential detections of water ice in the lunar soil at the South Pole. And this image here shows you in these light blue areas that we suspect may have water ice. The red lines there that you see are the anticipated travel route for the Viper mission as it moves around the South Pole. So this is very important, of course, because you can't take a lot of water with you when you are traveling in space. It weighs a lot, as we say, pints a pound the world around. And so they're going to have to find water and in a word, live off the land when we go to the moon and when we go to other places. So this will provide a lot of hopefully positive discoveries, that there's water in the South Pole, that it's accessible, and that the astronauts will be able to use it not only for water to drink, but to pull it apart and create oxygen and hydrogen for propulsion. So this is an important mission.
Lou, just looking at the predicted route that it's going to take, do you know roughly how far it is and how long the actual mission is?
The mission is about 100 days. It'll take a few days to get to the moon. I'm not sure if that few days is included in the 100. And then once it lands, it will, as we saw, it can move at about half a mile an hour. Yeah. As long as it has sunlight. Of course, it will stop when it gets a neutral ion detection. It will stop and sample the regolith and do its measurements, its other measurements before it moves on. So I don't know exactly how long that track is, but it can't be it can't be too long at a half.
No, I was just thinking that.
No.
Yeah, they must be quite close together. Those craters. Oh, it's very interesting.
Must get the map out and see exactly where it is. But it looks like it's going through the shadowed area on the left there. That's within a crater, presumably.
You of course want to go in shadowed areas as long as the slope isn't too great.
Yeah,
that's where you expect to find the water ice.
Exactly. So that's actually going to go down into a crater by the look of it.
That'd be interesting. Yeah,
it will have to. Yes.
Wow, I can't wait to see the images from that. That should be spectacular. Right. Okay. Well, there we are. So that's the Viper mission coming up, and we'd like to say thank you to Lou for telling us about that, because it's later this year, due for launch, and we look forward to it. Okay. Moving on. Sorry, Lou.
Comment when we get near the new year, we often have newspaper articles that say what's out and what's in, right? What's out for the old year, what's in for the new year. And it seems to me that this year, what's out is Mars. The Mars sample return mission is all but dead.
Yeah.
And what's in is the moon.
The moon. This is the year of the moon. It really is, without a shadow of a doubt. So this is good news. Because at least we know now that we can get to the moon, we can land on the moon. Had a few mishaps, but that's the nature of the beast. So we look forward to a remaining good moon year. So there we are. So thank you very much, Lou. And do keep us posted on any developments with that, obviously. Okay, well, let's move on now. And last item this evening, we welcome back Keith to talk about astrometry. And we've had people already tonight in the chat, Keith, asking if they'd missed the astrometry and when's the astrometry happening. So you've got some enthusiasm going there about astrometry. So let's just put up your presentation, and over to you, Keith.
Yeah, the headliner.
That you're the main movie, the main feature.
Right. Yeah. Well, this week we're going to have a look at how we measure things in the solar system, how we do it now, and how we did it in the past. And it's really quite ingenious the way that people worked out the distances to objects in space before the space age. First of all, let's have a look at the Earth and the Moon. And we'll start with this chap, Aristarchus of Samos, who was more or less contemporaneous with Eratosthenes that we mentioned last week. And as you recall, Eratosthenes worked out the circumference of the Earth. And that's a starting point for Aristarchus's work, in which he tried to work out the distance to the moon. And in fact, the picture on the left-hand side of this slide is in fact actually a 10th century AD transcript copy of his original work. A lot of this early Greek astronomical work was lost when the Library of Alexandria was burned down by the Romans, but fortunately this did survive. Anyway, basically the starting point is how big is the moon? And what Aristarchus realized was that if you watched a lunar eclipse, you could see the moon moving into the Earth's shadow and then moving back out of it again. And by looking at the size of the shadow, you could determine how big the moon is compared to the Earth. Now, he did make an assumption here that the shadow cast by the Earth onto the moon is essentially like a big cylinder, that it doesn't taper. And in fact, because the sun is 400 times further away than the moon is from us, that's not a bad assumption to make. And as you can see in the picture there, the moon is approximately a quarter of the Earth's shadow diameter, which in modern terms means it's round about 3,000 kilometers across, a bit larger than that. Anyway, so basically the radius then about 1,600 kilometers. And if we move on to the next slide, this is the second stage in his thinking, which is what is the angular size of the moon in the sky? And it turns out it's actually quite small. If you look at the full moon in the sky, it only covers about 0.5 degree of angle. And of course, the radius, therefore, of the moon is only 1/4 degree. Now, if you know that angle, which is alpha in the diagram at the bottom, it's about 1/4 degree, and you know the estimate of the radius of the moon to be about 1,600 kilometers from using the Earth's shadow, then you can do some simple trigonometry, because the radius is the opposite side of a right angle triangle, and obviously the distance is the adjacent side, and the angle is alpha. So all you've got to do is do the trig, as they say. And indeed, when you put the numbers in, and I've done it here, you can see you get an answer of round about 370,000 kilometers, which is pretty close to the known distance today. So Aristarchus knew pretty well how far away the moon was from the Earth, just using simple mathematics. Of course, today we've got a more sophisticated method. On the moon, there are 3 laser retroreflectors. They're in a bit like a giant version of the reflectors that go on the back of bicycle mudguards. And they were left by Apollos 11, 14, and 15. Most people don't know this, though, that there are also 2 more reflectors on the Soviet Lunar rovers, which were placed on the lunar surface in the, if I remember correctly, the early 1970s. These were rather typical Soviet engineering. They looked a bit like soup tureens with wheels attached to them, and they wandered around on the lunar surface. Anyway, using these reflectors, we can work out how far the moon is from us, because if we send a laser beam up to the moon and wait for that laser beam to be reflected back, the travel time should tell us how far away the moon is, because we know what the speed of light is. So that's basically the idea, but it's actually in practice quite tricky to do, because the laser beam disperses, it widens the beam as it travels away from the Earth, and by the time it reaches the moon, you've got to spot the several kilometers across, which means very little of the laser beam is actually reflected by the suitcase-sized retroreflector. But nonetheless, we get enough of it back that we can actually determine the distance to the moon. And if we look at the panel here, you can see this is an example using a 3.5 meter telescope. Basically, you send the laser beam out in pulses, and the pulses are very short duration indeed. They're in the order of picoseconds, millionths of a second. And as a result, each of the little blips of light is only round about a couple of centimeters in length. Now, they travel out to the moon, they disperse a bit, they get reflected back and dispersed a bit more. And by the time you get back to the Earth, the laser beam has in fact actually, you've got very few of the original photons, particles of laser light left. But, and to give you an idea, I've done the calculation at the bottom left there, you've got 1/10⁻15 of them left. But that still means you've got a lot. And because the laser beam is finely tuned and has a single wavelength, if you tune into that wavelength with your detector, then you can separate the return signal from any other ambient noise, if you like, other light that might be entering your receiver. So here we have, on the right here, the spike showing the return signal from the moon. There's 3 of them there, shown there. And at the bottom, the graph shows the return time for the signal to the moon and back. And you can see the graph is decreasing. And the reason why the return time is decreasing on this graph with time is that the moon's rising over the horizon and moving upwards to a position, well, sort of overhead. And as a result of which the distance between us and the moon is decreasing. whilst the experiment is in progress. Anyway, basically, here's some numbers. 80 picosecond bursts give you 2.4 centimeter long blips. The return time to the moon is about 2.5 seconds. And basically, therefore, it takes about 1.25 seconds for the light to go to the moon and 1.25 seconds for it to come back. And if you know that the speed of light in a vacuum is 300 million meters per second, you can work out how far away the moon is, and you get an answer, as you can see, bottom left there, of 378,000 kilometers. Now, you'll appreciate that with very small blips like that, we can get a very fine resolution on the distance to the moon. And that's proved to be rather interesting because we can show year on year that the moon is gradually spiraling away from the Earth. Its orbit is increasing in radius all the time. And this is due to the tidal bulges on the Earth pulling the moon forwards and speeding it up a little bit, and therefore moving it into a further out orbit. So it's been spiraling away from the Earth for some time, actually. And if we look at ancient corals in rocks from 400 million years ago, the growth lines in the corals, and you can see an example of this is a specimen in my backyard. You can see the growth lines in these corals here. We can show that, in fact, there were 400 daily increment growth lines in corals per year about 400 million years ago. So we've lost about 35 days in a year because as the moon is spiraling away from the Earth's rotation is changing, and therefore the day length is changing as well. And this has been going on for hundreds, if not billions of years. And here's the most amazing thing of all. If we bounce laser beam signals off the moon, we can not only show the movement of the moon, but also if you use two transmitters, one on the Eurasian plate, say over in Europe, another one in North America, we can show that the telescopes from which the signals are sent are actually moving apart due to plate tectonics of the Earth. And that is also detectable using these laser signals sent to the moon and back. Well, Aristarchus didn't stop at measuring the distance to the moon. Having determined the distance to the moon, he then thought, I wonder if I can work out the distance to the sun. And again, he's used trigonometry in a right-angled triangle. He waited until the moon was exactly at first or last quarter, so you see half of the phase, and tried to measure the angle between the moon and the sun in the sky. And he got an answer of about 87 degrees. And in fact, doing that, he got a distance to the sun of just a few million miles. The problem with the experiment was that, in fact, in practice, the angle wasn't 87 degrees. It's very, very nearly 90 degrees. It's not much less than that, about 89.3, if I remember correctly. But had he been able to measure that angle more accurately, he would have got a distance to the sun quite accurately. And it is remarkable that he thought of doing this, even if the answer wasn't necessarily perfect. So there we go. This is just some text that backs up what I've just said, so I'll skip on. In fact, here's the angle. It was 89.85 degrees, so very, very nearly 90. And as you can see, if you do that, you get a distance of 147 million kilometers, which is about right. It's about the distance between the Earth and the Sun. Now, just quickly, we're going to skip through Kepler's three laws. Kepler, as you know, was a 17th century astronomer who studied under Tycho Brahe and came up with laws of motion for planets in the solar system. In fact, he did what most scientists do, actually. He blundered around in the dark for ages, getting it wrong, before finally hitting on the right solution. And the solution consists of the following. The first thing is he realized that planets, and indeed any object that orbits around any other object, moves in an ellipse. And of course, a circle is just a perfect, uneccentric ellipse. So circles and ellipses are essentially the same thing. The second thing he realized was that as planets move around in an ellipse, they sweep out equal areas in equal times. So area 1 and area 2 in the left-hand diagram are the same area. So given that that's the case, the planet must move faster between P1 and P2 than it does between P3 and P4 in order to achieve the area rule. By the way, if these areas are equal, then of course you can apply Kepler's second law to pizzas, as you can see on the right here. Every one of those slices should be the same area as every other one, although I don't think they've been cut quite that accurately, but you get the idea. Okay, so it's the third law, though, that we're most interested in of all, because what Kepler realized was if you took the time for a planet to go around the sun, which we'll call its period, T, and the semi-major axis of the planet's orbit, that is half the long length of the ellipse, and in a circle it'd be the radius, then in fact the square of the time to go around the sun is proportional to the cube of the semi-major axis. And all you have to do to take that proportional symbol out and put an equals in instead is to put a constant into your equation. And in fact, Newton later determined that the constant was a thing 4 pi squared over gm, where m is the mass of the object that's been orbited around, which in the case of the solar system would be the sun, and g is the universal gravitational constant. But we don't need to use that. We can actually work in much simpler terms. If we use the units of 1 for the Earth's period, i.e. 1 year, and use the distance between the Earth and the Sun to be also a single unit 1, we'll call an astronomical unit, then in fact we can work out the relative distances of other planets from the Sun compared to our own, using Kepler's third law, modified in the way at the bottom there, which I'm not going to worry you with that, but that's basically what we do. And if we do that, all we've got to do is watch the planets move around the sky and determine how long it takes them to go around the sky once, effectively. And Mercury does it in about a quarter of a year. On the other hand, Saturn takes very nearly 29 and a half years. And of course, Mercury through to Saturn would be the planets that Kepler knew about, because Uranus and Neptune weren't discovered until later on. And anyway, if you feed the formula in for the Earth, you've got a period of 1 year and a semi-major axis of 1 astronomical unit, we can apply the formula to determine the other planets' distances, and we end up with this. So Venus, for example, is about 3/4 of an astronomical unit from the Sun, and Jupiter, for example, is just over 5 astronomical units from the Sun. So Kepler and his contemporaries did know how far away planets were from the Sun relative to each other and relative to us. But what we didn't know for sure, because Aristarchus hadn't done it very well, unfortunately, was what 1 astronomical unit is. In other words, what is the distance between the Earth and the Sun? So that required a bit more thinking. And in fact, it wasn't long after Kepler's time that somebody came up with an answer. I'll just skip past that. Basically, a Scottish mathematician, James Gregory, realized that if we looked at the transit of Venus, that is, watch Venus crossing in front of the Sun, from 2 different positions on the Earth's surface that were wide apart, we would see it at different angles, and therefore we could determine how far away it is. Now, if you can work out the distance to Venus, then of course by deduction we can then work out how far it is to the Sun by extrapolation. But the problem with looking at transits of Venus is they're incredibly rare events occurring hundreds of years apart in pairs. And as you know, we had some relatively recently in 2004 and 2012, but we won't see another one for a long time. So basically, not surprisingly, it was about 100 years later before any successful measurements were made using Venus transits. And in fact, actually, there had been attempts prior to that, but they've not been successful. So basically, here you've got a sort of diagram, two positions on the Earth's surface. We'll see Venus cross the sun in two different positions because we're looking at it at different angles. And that's basically what happens. And in the top left diagram there, the picture there actually shows a real pair of images of a Venus transit taken from two different places and one shoved on top of the other to show you that the Venus looks to be in a different position from one place to another. So that's basically the idea. And of course, what Gregory realized was that if you had two observers, A and B we'll call them, which you can see in the diagram there, looking at Venus, then in fact actually they could determine not only the distance between them, because that's on the Earth of course, but also they can determine the difference in the angle of view that they're seeing, which is marked here as V/2. And if you know the distance between the observers and you know the angle between the two views of Venus, then you can determine with trigonometry the adjacent side of the triangle D, which is the distance that you require to Venus. In fact, actually, as you can see, this diagram shows you two right-angled triangles stacked on top of each other, back to front. But in fact, in practice, the angle is so small that you can use the whole triangle and still get essentially the same answer. So that's basically what they did. And they had to measure the angle of view very, very accurately indeed from two different places. And remember that back in 1761, this would have involved a long voyage in a sailing ship. They had no cameras, and so the records had to be brought back and everything analysed afterwards. This is quite a remarkable thing. Anyway, that's basically what they did, and they determined the distance to Venus, and thus by deduction found the distance to the Sun. By the way, Edmund Halley, of Halley's Comet fame, himself did want to do this, and indeed this is one of his papers on the subject, you see on the left-hand side there. But he was frustrated by the fact that other astronomers that were asked to collect readings for him from different places failed to do so with sufficient accuracy, which is why it wasn't until 20 years after his death that in fact finally a Venus transit was recorded with sufficient accuracy to determine the distance to Venus. Incidentally, you'll see also from the same period here, somebody observing the transit of Venus, except of course that lady there would be blind in doing so because she's looking at the sun through a telescope. Never mind. Anyway, so I decided to have a go at this myself, and of course I can't wait for another transit of Venus to occur. That's a long way off. So what I did is I took the software Stellarium and looked at two views of Venus from two positions on the Earth, which you can see here. And I've substituted the image one on top of the other so you can actually see the difference in the view. So you can see it's a very, very slight difference between the North Pole and the equator, as you can see here. Somebody's bound to ask, why didn't I take the North Pole and the South Pole? And the answer is that when the North Pole's in sunlight, the South Pole's in darkness. Basically, if you take two positions, as I did here, you can see that Venus is slightly differently placed, and we can measure the angle between them, or try to at least. It's very much an estimate, and then put the figures in. So I did, and this is what happened. I found we had about a 90th or nearly 100th of a degree of difference in angle between the two views. and therefore that placed Venus round about 35 million kilometers away, given that the two observing positions I chose were around about 1 Earth radius apart, which is about 6,400 kilometers different. And if you then work that out, you can then move on to work out the distance to the sun. And I got an answer of 125 million kilometers. Now, you'll appreciate that isn't the right answer. It's 150. But it just shows you, in fact, how difficult it is to measure the angle correctly. But nevertheless, I had a go, and I nearly got it right. Of course, we can now measure the distance to Venus, and indeed Mercury, and probably Mars as well. I don't know if they've done Mars, using radar. The giant Arecibo radio telescope, which, as you know, doesn't work anymore, was used to bounce radar signals off planets to determine distances to them. And in fact, you get a bonus, actually, because the radar that's reflected off Venus and off Mercury can also show you that these planets are rotating. Admittedly, with Venus, it's pretty difficult because it rotates very, very slowly. And also, you can actually get sufficient detail with radar signals from the Earth to actually plot out surface features on Venus. So quite a remarkable thing to be able to do. Anyway, basically, what you do is you send your radar signal out, it bounces off the planet, comes back again, and using the travel time, then you can determine how far away the planet is. If you think about it, all we're doing is using microwave radio waves to do the same thing we did with the laser beam to the moon and back. It's the same technique, just using a different part of the electromagnetic spectrum. And there was a time, and I don't think it works anymore on modern computers, that you could actually do an experiment yourself, a sort of simulated experiment, because Gettysburg College in the United States had a wonderful set of programs under a thing called Contemporary Laboratory Experiences in Astronomy, or CLEAR for short. And one of them was, in fact, working out the distance to Mercury using radar waves. And I've taken a screen grab from that program. You can see down there at the bottom. So that's basically what you can do with radar today. And with Mercury, it did give us one additional piece of information, which came as a bit of a surprise. When I was a child, it was confidently assumed that Mercury kept one face towards the sun as it went round, just as the moon keeps one face towards the Earth as it goes around. In other words, captured rotation. But with the radar signal showed, in fact, that Mercury actually rotates, and it rotates 3 times for every 2 orbits, or 1.5 rotations per single orbit. So there you go. That's how we determine the distance of things in the solar system.
Fantastic.
Oh, fantastic. Cheers, Keith.
Thank you so much for that, Keith. Wonderful. And you will be doing a part 3, I understand.
Yes, the next one is we're going to look at how we determine the distance to stars using parallax. And of course, this has really taken off in the last sort of 30 years because using orbiting observatories, we've been able to determine the parallax to many, many more stars than was previously possible.
Wonderful, wonderful. Okay. Would you like to do that next week, Keith, if you're ready?
Yeah, I think I can get it ready for you, yeah.
Okay, so we'll look forward to seeing the 3rd part of Astrometry from Keith, all about parallax measurements to the stars, next week here on Space Oddities.
Can I make a comment or two?
Certainly, of course.
Keith, that was brilliant. That was absolutely brilliant.
Thank you very much, Luke.
Very nice description of distances in the solar system. I had the chance when I was in Manchester some years ago to go by the home of Jeremiah Horrocks.
Oh, yes.
So Horrocks and his colleague William Crabtree were the first to see a Venus transit in 1639. And I believe that they were able to predict and see it because, I think this is right, Isaac Newton made a calculation to predict the next transit of Venus when they were all, well, originally they thought they could get the size of Venus from it. And at some later point, they realized, we can get a distance. But Newton did it in his theoretical way by calculating the distance from the center of the Earth, not the surface of the Earth. So Horrocks got it right. He was the first person to see it. I was able to see the transits of 2004 and 2012. 2012 from Mauna Kea in Hawaii, just the most exciting thing I've ever done, almost. And the next Venus transit will be December 8th, 2125. But here's an interesting figure for you. The next transit of Earth, as seen from Mars, will be November 10th, 2084. So get Mars back on the docket. Maybe we'll be able to see the Earth passing in front of the sun as seen from the surface of Mars.
Wow, that would be good, wouldn't it? If there were colonies there.
Excellent. So thank you, viewers, for your kind comments. You've got some fans there, Keith, and people say they're looking forward to next week. So will everybody. So we'll look forward to the third part of Astrometry next week. So that just about brings us to an end for this evening. Thank you, viewers, for being with us. And thank you for the coffees that I see have been brought for us. Much appreciated. We will be back, of course, at the same time next week here on Space Oddities. And we will have Keith, as I said, talking about astrometry, the third part of his presentation. And we'll have the usual lots of other stuff as well. So from us all at Space Oddities, we'd like to wish you a very good evening. Have a fantastic week. Look after each other. Be good. And if you can't be good, be average. And from myself, from Daz, from Roger, from Michael, from Lou, and from Keith, we'd just like to say thank you for everything. Thank you for your support. And we'll see you back here on Space Oddities at the same time next week. Just before we close, just to let you know, in case you haven't already seen it, Daz has produced a wonderful video about the recipe for life in the universe, all about the chemical elements needed for life and where they come from. So that is available on the channel now. And we hope you enjoy it. And don't forget, if you want to watch it again, we have our live coverage of the Odysseus landing on the moon from last week. And that's on the channel as well. And do have a look at all our playlists on the channel, because we've got in total over 200 different videos available. And we're always creating more to just convey our passion about the universe to you, and we hope you enjoy them. So from all of us at Space Oddities, have a fantastic week, and we will say goodbye. So goodbye.
Goodbye. Thank you, everyone.
Goodbye.